At the edge of our understanding lies a mystery, a strange, unseen force shaping the cosmos. Black holes, the ultimate abyss, a place where gravity crushes everything, even light, into oblivion. But what if, at their core, something else exists? A hidden object made of exotic matter defying physics as we know it. A possible answer to the universe's greatest mystery, dark energy. Could these strange objects be real? Could they be gravastars? For decades, black holes have remained the ultimate paradox, massive objects so powerful that even light cannot escape. But at their core, something even stranger happens, something that breaks the laws of physics themselves. According to Einstein's general relativity, black holes should collapse into a single point of infinite density, a singularity. But infinities don't exist in nature. The laws of physics stop making sense, and that's a problem. Then there's the information paradox, one of the greatest unsolved mysteries in modern physics. According to quantum mechanics, information can never be destroyed. Yet black holes seem to erase everything that falls into them. If black holes destroy information, then something is deeply wrong with our understanding of the universe. That's why in 2001, two physicists, Pauel Mazur and Emil Motola, proposed a radical alternative. Their idea? What if black holes aren't black holes at all? What if, instead of forming a singularity, a collapsing star transforms into something entirely different, something called a gravastar? Instead of collapsing infinitely, the star's core turns into an exotic form of energy, pushing outward with just enough force to counteract gravity. The result? A nearly weightless, vacuum-like interior surrounded by an ultra-dense shell. On the outside, gravastars would look just like black holes, dark, massive, and impossible to escape. But inside, there's no singularity, no infinite density, just a strange, exotic bubble defying the rules of physics. If gravastars exist, they could even be the hidden source of dark energy, the force accelerating the expansion of the universe. But if gravastars exist, why haven't we found them? And if black holes aren't really black holes, what are they? Could gravastars actually be hidden in plain sight? In the next chapter, we search the cosmos for evidence and face the biggest challenge, yet proving they exist. Push bin subscribe now. A gravastar is a star that should have become a black hole, but didn't. Instead, something stopped it, something we barely understand. Instead of forming a singularity, where gravity crushes everything into infinite density, the core transforms into something else, a bubble of energy so bizarre, it challenges our very understanding of space and time. At the heart of a gravastar is something called exotic vacuum energy, an unknown force similar to dark energy that resists collapse. It doesn't behave like normal matter. In fact, it pushes outward instead of pulling inward. Some physicists believe this strange energy is the same force that's accelerating the expansion of our universe. If true, that means gravastars could hold the key to one of the greatest mysteries in cosmology, dark energy itself. Surrounding this energy core is a shell of hyperdense matter, a barrier so strong, it prevents total collapse. This shell is so thin it might be just a few atoms thick, yet so strong that nothing, not even the most powerful forces in the universe, can break through. And this is where things get truly strange, because from the outside, this structure looks exactly like a black hole. If you looked at a gravastar from a distance, you wouldn't see anything unusual. It has the same mass, the same gravitational pull, and it even bends light, just like a black hole. This means that some of the black holes we've detected might not actually be black holes at all. What if everything we thought we knew about black holes was wrong? If gravastars exist, it means we've been looking at them all along without realizing it. But if these cosmic imposters are out there, how do we prove they exist? In the next chapter, we follow the search for the ultimate proof, evidence that could rewrite astrophysics forever. In 2019, the Event Horizon Telescope captured the first ever image of a black hole's shadow. A triumph of modern science. But what if that shadow wasn't a black hole at all? What if it was something else, something we've never truly seen? Black holes are the undisputed kings of gravity. But now, a challenger has emerged. A cosmic imposter so perfect, even light can't tell the difference. It's time to put them to the test. Black holes trap matter with an event horizon, a one-way door into oblivion. Anything that crosses this invisible line is lost forever, spiraling toward an impossible singularity. But gravastars? They have no event horizon, no point of no return. Their shell is made of exotic matter, so dense it repels everything that touches it. Imagine dropping a bowling ball onto a trampoline only to watch it bounce back at you. Some scientists believe this is exactly what we're seeing. Could these unexplained flares be our first glimpse of a gravistar in action? Now, the biggest difference of all, what lies at the heart of these cosmic giants? A black hole singularity is where math dies. Einstein's equations break apart, reaching an impossible infinity. But gravastars cheat. Their cores don't collapse into an infinite point. Instead, they stabilize, creating a bubble of exotic vacuum energy that pushes back against gravity's pull. Think of it as nature's undo button for infinity. If gravastars exist, why haven't we found them? The problem is, they look exactly like black holes from the outside. Their gravity is identical. Their light-bending effects are the same. But there might be a way. In 2023, physicists analyzed old LIGO gravitational wave data and found something strange. Black hole mergers should produce a clean chirp, like a bell struck once. But if a gravistar is involved, the collision might ring space-time like a gong, vibrating long after impact. The hunt is on. Black holes and gravastars are locked in a cosmic masquerade. But what if we've been looking at gravastars all along without realizing it? If gravastars exist, they're not just black hole doppelgangers. They might hold the key to something far grander, the origin of our universe itself. Could gravastars be the missing link between black holes and the birth of the cosmos? In the next chapter, we rewind time to the very first second of existence. The Big Bang Theory tells us our universe began as a tiny, hot, dense speck. But where did that speck come from? Some physicists like Nikodem Poplawski propose a radical idea that our universe wasn't born from nothing but was forged inside a gravistar from a parent universe, a cosmic Russian nesting doll with realities stacked within one another. In 2001, physicists Powell Mazur and Emil Motola developed equations that challenge our understanding of black holes. Their theory suggests that a collapsing gravistar doesn't form a singularity. Instead, its core inflates exponentially, mimicking the Big Bang's expansion. In their model, the universe isn't a one-time event. It's a phase transition, like water freezing into ice. A transformation, not an explosion. If our universe began inside a gravistar, it might have left fingerprints in the cosmic microwave background, the afterglow of the Big Bang. Some physicists believe these cold spots could be scars from a cosmic event before the Big Bang, perhaps the remnants of a gravistar collapse. But we'll need next-generation telescopes to know for sure. If this theory is correct, then every black hole we see might be something far greater, a gateway, a cosmic womb, a seed from which a new universe could emerge. Every gravistar could be a doorway to a new universe, each with its own laws of physics. Picture a fractal. Infinite realities branching from dying stars, each bubble expanding into its own cosmos. This isn't science fiction, it's a prediction from some quantum gravity models, including loop quantum gravity theory. If this theory is correct, then the Big Bang wasn't a one-time event. It was just one of many. And if every black hole in our universe is a potential gravistar, then how many more universes could exist? Could our own reality just be one of countless others? But if gravastars birthed our universe, what's fueling its expansion today? The answer might lie in the most mysterious force of all, dark energy. And gravastars could be hiding in plain sight as black holes. In 1998, astronomers made a shocking discovery. By studying distant supernovae, they found the universe wasn't just expanding, it was accelerating. Something unseen, something powerful, was pushing space apart. We call this force dark energy, the most mysterious component of the cosmos, making up nearly 70% of everything. But what if we've been looking for it in the wrong place? What if it's leaking from gravastars? Unlike black holes, which trap everything, gravastars may be slowly leaking energy into space, a hidden force stretching the fabric of reality. But how? The answer may lie in quantum tunneling, a strange effect where particles can pass through barriers they shouldn't. Gravastars aren't perfectly sealed. Their vacuum energy could slowly tunnel through their ultradense shell, a slow, cosmic leak, powering the universe's expansion. It's like a battery steadily releasing energy into the universe. And when physicists crunch the numbers, the energy trickling from millions of gravastars could match the observed strength of dark energy. This would mean that black holes aren't just cosmic graveyards. They aren't endings, they're engines. Right now, most physicists believe dark energy comes from the quantum vacuum, the energy of empty space. But there's a problem. The numbers don't add up. The predicted strength of vacuum energy is 120 orders of magnitude too high, the biggest calculation error in physics. Gravastars offer a radical alternative. What if dark energy isn't coming from empty space at all? What if it's coming from black holes, or rather gravastars spraying energy into the cosmos like invisible geysers? If gravastars exist, then we may have just solved the greatest mystery in astrophysics. What if the universe isn't expanding into nothing? What if it's expanding into something? And what if we're about to prove it? The James Webb Telescope is scanning black holes for X-ray echoes. The LISA gravitational wave detector, launching in 2030, will listen for gravistar collisions. If they find proof, everything changes. Black holes aren't endpoints, they're engines of creation. Throughout this series, we've uncovered a hidden thread, a theory that could explain it all: the Big Bang's true origin, the mystery of dark energy, and the fate of matter falling into so-called black holes. But until we hear their gravitational echoes or detect their X-ray flares, gravastars remain ghosts, lurking, hidden, waiting to be discovered. What if we've been looking at them this whole time without realizing it? As physicist Lee Smolin once said, a black hole is a door to another universe. But what if that door is a gravistar, and we've been knocking on it for decades? In the next decade, we'll either prove gravastars exist or rule them out forever. Either way, the universe is stranger than we ever imagined. And the truth? It's hiding in plain sight,